our next test is. So our next test is going to be the 18th and 19th, which is pretty soon. This will be our second test. And then after that, things are going to be pretty full speed ahead. And it always gets this way. It's like after Halloween, everything gets really quick. So right after that exam, we're going to have a very short little mini reactions unit and then a 9 weeks test. And once that 9 weeks test happens, then it's going to be finals. So believe it or not, we've almost made it through an entire semester. It's crazy. One really important thing that I wanted to make sure that all my virtual learners know is that finals are actually going to be on a synchronous schedule. So what that means is when it is time for your final, you have to take it during the time period in which you are scheduled to take it as if you were a in-person learner. And that was not like a decision that came from me, but it is really, really important that if you're scheduled, if you're in fourth period, that you take it when the other fourth period students will be taking their final. And I'm going to post that schedule for y'all, just so you know. And I'm going to be reminding you about that every single week until finals, because I don't want any of you who are my wonderful students just making a mistake and logging on the wrong day and accidentally losing points. So things will be happening pretty quickly from here on out. And it always gets that way at the end. But y'all are doing so well. So I'm actually going to share my screen with y'all so you can see my new module that we've put up to help with our extra credits. So I'm going to do a share screen. Okay. Now I'm gonna hopefully get that up where you can all see that. Okay. Here we go. Okay. Share. All right. So can we all see? Everyone can see my screen?
Yes, ma'am.
Perfect.
Yes.
Perfect, perfect, perfect. Okay, so I added this module today. So I already got some emails asking about it, very eagle-eyed. So it says extra credit DIY labs. Okay, so if you click on this module, you're gonna get a whole list. And each one of these is like a little science experiment that you can complete at home. And most of them are using really easy to come by materials, like, for example, this mini lava lamp. I made this before. It's super fun. It's just like oil and water. I did it with my daughters. So each one gives instructions on how to do the lab and like a little bit of background information. So you wanted to do one of these experiments, and there's a whole bunch to pick from. What you'll do is complete the lab and make sure you take a picture or a short video with you in it. You have to be in it because otherwise you could just, not that y'all would, but some students might try and just Google something and take a picture. So once you've completed that lab, you can do a Flipgrid video. And in your response, all you have to say is your name and the class period you're in. And so I have my daughter's doing that. And if you want to just have a picture, that's fine too. A video would be great. And for each one of those labs that you do, each lab you do, you can get 10 points added into your major grades category, up to 5. So if you do 5 of them, it would be half a major grade as extra credit.
Ooh, that's good.
And so that's like, students are usually excited about this because it's honestly a lot more fun than doing lots of Canvas quizzes, because they're all fun little things. And we do have a few that are purely just computer based in case you don't have those materials, and it is just extra credit. So, but it is up to half a major grade. So that could be a huge help if you weren't very happy with maybe your last test or maybe your grade the first 9 weeks, because remember, it is what really counts as your semester average. So if you're looking for an easy, fun way to boost your semester average, that's why we've created that link. So that's in your modules. It's called DIY Extra Credit Labs. And the main restriction is, one, you got to put yourself in the pictures. Make sure you add yourself in the photo or video. And 2, up to 5. And the due date on that, and it says in here, they all need to be submitted by December 10th. So that way I have time to finalize your grades. Does anyone have any questions about that?
No, I'm good. It makes sense. I quite enjoy this. This is helpful.
It's really, it's meant to be like really, really fun. I enjoyed making them. So hopefully that'll be super fun. Now today's homework, it was just not going to work out doing a Canvas quiz because I really needed y'all to have practice with the drawing out your structures. And I don't think really, I think y'all have gotten very good at photo uploads, but if anyone has any issues doing the photo uploads, please let me know if that ends up being a problem, but I suspect that it should be just fine. And this is really our last big instructional day for this unit before our exam, and we'll spend the next two of our classes before the test reviewing. So I'll probably do a pretty big review video. So that was mainly why I wanted to come on and talk to y'all today. And plus I could answer any other questions if anyone has any questions about anything.
I have one or maybe a few questions.
Maybe two.
Yeah.
Go for it.
Okay, so when we're doing like the Lewis dot structure to figure out like the little, what's it called? Like if it's either a bent one or like a trigonal, what's it called or whatever, how do you know what element goes in the center?
Okay, so that's a really good question. Typically, it's going to be the one that is by itself. Like if, for example, if I'm looking at H2O, right? Like sheet, or a ASF3. What I mean by the one that is by itself, it's typically going to be like an H2O, for example. Actually, maybe I can switch you to document camera. Let me see. Yes, I can do that. All right. Okay, so for example, like CO2, C typically is going to be at the center of that because it's the one that's by itself. It's not, so usually the ones like O would not be the center of that. So, and then another example like H2O, O would be the center because it's by itself.
Okay.
Does that make sense?
Yes.
So here you kind of have to decide, is it going to be carbon or is it going to be the chlorine, right? Because it's definitely not going to be the H's. The way I want to think about that is how many bonds does each one need to complete its octet? Carbon needs to make 4 bonds, right? Whereas chlorine only needs to make 1. So it wouldn't really make sense that chlorine was in the center because chlorine only needs to make 1 bond. But if you put carbon in the center, this needs 4 bonds in order to have a full octet, right?
Okay. Yeah. Yeah,
so
that does.
That's kind of how I always think about when I'm drawing them is, okay, what do they need to bond in order to fill up their octets? And it's really easy when they're ones like CO2 or H2O. Yeah. So that's the best way to do that.
Okay, thank you. And then Yeah, thank you. Okay, so I think this is the last one, I think, but with the negatives. So it'll have like I don't know, like uh H2O or something like that, right? And then it'll have like the O, I don't know, it'll just be elements, and then it'll have like
A
a
negative
3,
sign?
and yeah, that. How does that work?
That is, I wonder if I can find an example in your packet from that, so I'm not just drawing one out. Usually the reason that happens is because there's no other way for the octet to be correct without there being some kind of a negative sign there. Like, and I need to find an example of how that's, I wish I had that in front of me, but I just had today's homework printed out, which of course did not have one of those.
Sorry.
Oh, okay. So like, here we go. I found one. So the only way this one can have octets of 8 is if it has these 2 extra electrons. So when you see a negative sign there, it's because if it was just SO3 and I just tried to draw out SO3, these octets would not be complete. That -2 allows me to have 2 extra electrons, so all the octets are complete the way they should be. Because
okay.
See, without that -2, there'd be like no electrons there, and this would not be a stable molecule without those extra electrons.
Okay,
so that just
makes
gives it
sense.
stability. So, and the same thing over here, this has 1 less electron for the same reason, right? So
how would that look?
Okay, so normally NH4, so this is going to be, so nitrogen, let me move things here. My keyboard in the way. Whoop, dropping my mic. Like drop, but actually dropping it, not making an emphatic point. Okay.
Yeah, they're all impacted points.
That's true, that's true. Okay, so NH4. So nitrogen normally would look like this, right? 1, 2, 3, 4, 5 valence electrons. But look, it's actually here. That doesn't make sense because look how many hydrogens are attached to it.
Okay.
Right? So yes. In order for this to work correctly, it just means it's lost one of these extra electrons. So this electron's gone. And now it makes sense that there would be 4 hydrogens attached to it.
Okay. That makes sense now. Thank you.
So really the positive and negative signs are only there to make the octets make sense. Right?
Okay.
Because we're not trying to break octet rules unless we're boron, which boron, boron's weird. Boron's always breaking the octet rule because boron never wants 8, it only ever wants 6.
Okay, got that. Thank you.
Very good question.
Thank you.
Does anyone else have any more questions for today? No?
I don't think so. Unless the other two.
No? No more questions from anyone else. Well, okay. Great. Look for those DIY experiments. I can't wait to see what y'all do. I hope you enjoy it. They're really fun. And I know I personally miss doing things that aren't on the computer. So hopefully that'll be fun for y'all.
Yeah.
Okay. Well, great. If anyone needs me at any time, make sure you reach out and I'll get back to you as soon as I can.
Yes, ma'am.
All right. Have a great day, everybody.
All right, you too.
Thank you.
Bye-bye.